Okay, so yeah. Hmm. So what is it like? Yeah, I was showing you, right, how the Fourier transform. We are interested how the Fourier transform of the mask looks like. Let me tell you one thing. The mask itself is nothing but in the, we'll assume that a mask that I created, right? A white circle in a black plane that is expected to be in the frequency domain. If at all I take the Fourier transform way, it will move into the spatial domain. Okay. I want to tell you one small thing. Wait a second. Let me show you how the typical time domain thing of that mask look like, or the frequency response of the mask looks like. Okay. So here is the hmm, here is the mask. Okay. So a nonsense image has popped up. A nonsense image has popped up. Why that happens, by the way? Which screen am I sharing? Okay. An image has popped up which has mostly black and white. You can see the image is a monochrome image because we have taken the Fourier transform. See, when you take actual image, there is a rule that all intensities are from 0 to 255. But when you take the Fourier transform, there is no rule that image value should be from 0 to 255. It can be double. Fourier transform is actually complex in nature. So the values are actually complex. But thank God we are not interested in the phase angle. We are only interested in the magnitude, or we can even manage with the real part of it. Okay, that's why to visualize this properly, what I will do is, here the values are so large. All the values greater than 255 are being shown as white. All the values less than 0 are being shown as black there. Okay, that is a problem. So let me apply the log transformation. You have studied log transformation, right? You have studied the log transformation. It has been given to you as a part of your, can you listen to me? Are you listening? Did you get what is the problem there? Hmm? When we check the mask, did you see that thing? Did you see that thing? When we check the mask, it was all blacks and whites there. Okay. So now that's why what I will do is, since I want to pick all the values, larger values I want to suppress below 255. Smaller values I want to enhance. Larger values I want to suppress, smaller values I want to enhance. So which is the tool? We just studied it in the previous chapter, right? It is the applying log transformation. Let us do that. Now what I have done here is I have taken a log 10. Okay. 0.1 into log 10. Just multiplying by taking a log may not be sufficient sometimes. So I will then reduce the value by 0.1 also. There I have evaluated selection, and let me show you if the mask has popped up. Okay. Now can you see the screen? Now there is the Fourier transform of the mask in the frequency domain. So I want you all to understand. The to see that ringing effect, the Gibbs phenomenon in the time domain. Now, can you see this particular thing? Can you see your screen now? What do you see, by the way? Do you see the rings here? Do you see the rings here? Hmm? Do you see the rings here? So it was a box. Remember, whatever I showed you, a rectangular pulse in the time domain is a sink in the frequency domain. A sink pulse in the time domain is a rectangular pulse in the frequency domain. So here, whatever I have got is nothing but this waves. Okay, they are nothing but these waves. All those values below 0 have simply gone black. They have simply gone black. Now that I have applied log, maybe and I'm picking the magnitude, but still black is black only, and all the white values, and that is why that justifies the thing. That justifies this entire thing. Now, do you see what I was asking you was? Can you see these rings here? Can you see these rings here? Somebody, please respond. Can you see these rings? Hmm? Can you see these rings? Yeah, thank you, thank you. So you can see this. So what I was telling you, just like the DFT, the two-dimensional DFT also. So what we want to do is, actually I wanted to have a circle. So if at all I pull this part to the center, all the values on the right of it, on the top of it, on the left of it, they will also be brought back. Since this is periodic in nature, remember, DFT is periodic. So what will be there on the left side? Same replica, they will be there on the left side also, on top also, and bottom also. Remember, they will be there on top and bottom also. So I just want to pull this particular thing. That's what that multiplication by -1, my multiplication by -1 to the power n was coming. Okay. So here A simple method to do so is nothing but I won't go and multiply with -1. I will use this ready function ffty shift. Okay, I will use the ready function ffty shift, and then I will show you how the masks look like. Okay, then I will show you how the mask looks like. Okay, now let us see. Okay, there I have it. Now do you see what has happened? Now that I did the multiplying by -1 to the power n or ffty shift, now you can see this is that particular rectangular signal in the time domain was the sync in the frequency domain. Now we started with the rectangular in the frequency domain. Remember, we were in the frequency domain. What I took ffty, it's dual, right? So what I'm getting is sync. Okay, this is the wave. Okay, black, white, black. You can see the rings. Are they good, by the way? Did you want those rings? Rings are not part of our plan. Yes, we wanted it to be light gray. As and when it goes to corner, we wanted it to be dark gray, fine. But the rings are not part of our plan. They need to be suppressed. Why the rings are coming? Remember, a rectangular window in the time domain, a rectangular window would give us the Gibbs phenomenon, the ripples at the edge of the transitions, ripples at the edges of the transitions. Remember, so same thing similar is happening here also. That is why in the next class we'll be studying the other types of window, the Gaussian and the Butterworth filters we'll be looking at. Anyway, today what we will do, let us anyway, the any doubts here, by the way? Was it convincing enough? The rings and why we need to move multiply by -1 to the power n, we saw earlier what happened. That is why ffty shift. Now we are ready to manipulate our image. Now let me go back to the image which I want to manipulate. It is here below. The image is here. So now I have this particular cameraman image. Now I have this we know this image, right? I need not show you. I will let me show you the Fourier transform of the cameraman image. Okay, ffty shift I'm once again using, and then I will show you the image. Okay, then I will show you the image. And by the way, multiplication by the logarithm is only for us for the displaying purpose. Okay, we can straight away go ahead with the manipulation. Only for the display we need to use the log. Okay, so here let me show you how the cameraman image, the Fourier transform of the cameraman image looks like. Okay, yeah. Here is the Fourier transform of the cameraman image. Let me tell you, it is not the proper image. All the values above 255 are shown as white. All the values below 0 are shown as black. Doesn't matter. Okay. So if at all you actually want to see this particular image, wait a second. Wait a second. Wait a second. Let me take the log. Here. Wait a second. Let me filter the image. Let me filter the image. What I will do is, I already have the mask. I will simply multiply the Fourier of the image with that of the mask. See here, what I will do is low pass filter mask the Fourier transform of my image which I have shifted, and I will multiply with the double of the low pass filter mask, because when I created the mask in the paint, I will get it from values from 0 to 255. That is why doing the data type conversion is very important. And this is nothing but the Fourier transform of my image and applied with ffty shift. ffty shift or IFFT shift, both are fine. Okay, my image Fourier transform applied, then applied with FFT shift. Both are same. I told you FFT and IFFT shifts are same. And then afterwards, the image has been multiplied with the mask which I had created. And type conversion is very important. Okay. Now let me show you the image, the resulting image. Let me show you. Sorry. Let me show you the resulted image. What sort of image am I expecting? It's a small mask. Okay, I did not even tell you what is the. Wait a second. Something happened. Okay. Wait a second. Be there. Yeah. Okay. So now, can you see the image? So what has happened here, by the way? The image has been filtered with a low pass filter, and I have multiplied it with some log factor, but you can see average intensity has been retained. Can you see the ringing effect here? You can see the coat. In this coat, inner side, there is an aura. He's looking like a god here, right? There is an aura around him. Okay, this is not good. He is not God. Okay, there is an aura around him. You know, this double lines. Okay, that's bad. That is bad, and that is called as the ringing effect. That's called as the ringing effect. So today we have seen a low pass filter, and we have seen how to create a mask. We have seen how to create a mask, and we have also seen how a low pass filter, ideal low pass filter, is giving us the ringing effect. Okay, see the ringing. Tomorrow what we will do is we'll see other filters, a high pass filter. What you do today, if at all you have PC, you have MATLAB, then you have fun with create your masks and check uh, how you can manipulate images. Okay, fine. Were we comfortable with this particular thing? Okay, so yeah, that was that image, and finally whatever was shown to you. I had actually, wait a second. I am sure. Mm, be there. Hmm. Okay. So I had multiplied that particular image with log because the image has gone bad because of, as I told you, numbers going more than 255. That is why I had multiplied that particular image with log 10 and a point 1. That is why because of that point 1, the entire image was looking a dark gray. Okay. If at all I do not keep the image as it is, then you can see this is what has happened. Anyway, you can see the edges have been picked here. Okay, there is nothing much to conclude. Okay, so we will stop here. Okay, we'll stop here. We'll continue tomorrow, so if possible. So have you tried that assignment, by the way? Did somebody try the assignment? Are you trying the assignment? Hmm? So the intention was, I am not going to beat you, or if at all you don't do assignment or anything. I want you to have a feel about the frequency domain manipulation. If at all you do things in the spatial domain, you realize the need for frequency domain, and the analogy or the relation will be much more easier. Okay, you will understand the difference and the ease which frequency domain gives. Okay, so those who are not done, please give a try today, and those who are having a laptop, have a discussion with your friends also. Okay, so today what is your assignment? Not assignment, be curious and try to have different masks. How do you create masks, by the way? In paint. Okay, take the center point, you create a circle, then do the manipulations the way I had shown you here on MATLAB, and have fun. Okay, thanks for joining. Bye.